on this change of the area. So let's pick your favorite rectangle.
Mhm.
And let's go 2 and 3 on that.
Mhm.
And this time, which of these numbers is multiplied by 4?
That would be 2.
2, because we consider that the height. So 3 and now 8. What is the area of this one on the left?
The area of this one is for the which one are you pointing to? The 8 times 3 or the
The
that
left.
would be 6.
Okay, and what is the area of the one on the right?
24.
Okay, so how does the area change?
It's multiplied by 4.
Very good. Okay, sorry, I'm just sipping a little coffee here, trying to get my get pumped up for this lesson. Okay, let's do the same thing here, but it's a parallelogram. It's kind of the same thing. It's actually asking about perimeter. So the base and height of a parallelogram. So both the base and height of the parallelogram are multiplied by 6. So let's do the same thing. Like, let's use a rectangle. Rectangle is a parallelogram.
Mhm.
What is the new base and height?
The new is it for both base and height. Okay. So 2 would be my height would be 12 and
Okay.
my length would be 18.
Okay, so I want you to find the perimeter of both and let me know what happened.
Okay. Did we do a perimeter for
No, but I'm asking you to just find the perimeter. The perimeter is a walk around. What is the distance all the way around?
oh okay. Never mind. So the small rectangle is 10.
Okay, and what's the large rectangle?
Large rectangle is 60.
Okay, so how do you go from 10 to 60?
You multiply by 6.
Very good.
I see. There.
Okay, so we can sort of generalize here. Lengths, which kind of perimeter is included.
Mhm.
You just use this value of k.
Ah.
Okay, area ends up being k squared. We actually covered this in a previous section, and volume is k cubed. So you find the scaling factor and then you either keep it, square it, or cube it. And I'm not sure why they are doing this, but we'll just go with it here. So let's look at the next question here, and we'll see if we can answer it keeping this in mind. Maybe we can, maybe we can't.
Okay.
But let's take a look here. So it says the diagonal of a rhombus is multiplied by 2/3.
Mhm.
So here's a rhombus. Well, let me actually, it doesn't really matter. So here's a diagonal of a rhombus. Let's call that 18.
Mhm.
And if we multiply by 2/3, what is the new diagonal?
I get 12.
12. Okay. Now the problem is that if you don't make them both change, like here's the other diagonal of the rhombus.
Is that also 18 or is that a different number?
Well, I guess what I was going to say is they both have to change. Like you can't have them be the same. Like we don't know what it is, but let's just say it was 24.
Mhm.
So now what is it?
Oh.
What is 2/3 of 24?
16.
16. So the area of a rhombus is 1/2 diagonal 1 times diagonal 2.
Mhm.
So I want you to find the areas of both of these, please.
Okay.
You can use your calculator, you can use Desmos, whatever you think will be best for you.
Okay, for the first one is 216 and the second one is 96.
Okay. So notice that it gets smaller this time, right?
Mhm.
So if you take 96 divided by 216, and you
Mhm.
could reduce that, you're going to get 4/9.
Oh.
Now, how did I know that? Let's go back and look at this picture I just showed you. With area,
Mhm.
what is the K? What do you do to the K?
You square it.
So what is 2/3 squared?
Oh, that's 4/9.
Okay, so now let's see if we can figure this out here without actually doing it. But like most students, you probably want to try some numbers, so that's okay here. So let's say we've got a circle, and let's say the radius is 2. Okay,
That's tripled, so that's 6.
so the new radius is 6. Now, before we do these calculations on the right,
Mhm.
the K is 3. So what should the new area be? It's K.
Oh, one.
Let's go
Wait.
back up here.
Oh, that should be. Oh, that should be 9.
Should be 9, right? So now let's verify that. Okay.
Oh.
So the area is pi times 2 squared, which is
Mhm.
4 pi. Pi times 6 squared, which is 36 pi. What is 36 pi divided by 9 pi? Or 4 pi? I just gave you the answer.
9.
Yeah. So knowing these like really makes the problems a little more straightforward. Okay, so we're going to do this one without the without actually putting in numbers. We're just going to use the K.
Okay.
The radius of a circle is multiplied by 1/4. That's your K.
Mhm.
So we want area. So with
So
area, what do you do with K?
you just square it.
Okay, so
Square it. Yeah,
no,
square it.
that's different. Square and
Sorry,
square is
square it.
different. It's like positive and negative on your battery. They're different. Okay, so what is 1/4 squared?
I get. Oh, I get decimal. I forgot. I have to go to decimals.
No, you don't have to. What's 1 squared? That's the numerator.
Oh, 1 squared. That's just 1, and that would be 1/16.
Very good. Okay, so last problem here. This one really fast makes up for the last few that have been really slow. See if you can do this one on your own. Figure out the value of K and then figure out what you need to do with it.
I get 16.
What is the value of K?
The value of k is is doubled. So
What is
it
the
would
value of K? What does that mean? What is
val
doubled as a number?
the value of k. So my radius is 2, and then I double that. That's 4, and then there's
No. What is your value of K?
2.
2. What is K squared? That affects the area.
Oh, 4.
Very good. Okay, so there was a small error in one of these other problems that we did. So it may be, and this is kind of one of those things we're going to remember for the test or the quiz. You know, when you're doing it on your own, is it appears that they meant just one diagonal, not both.
Oh.
So if you go back to that example that we did, we said, oh, diagonal 1 was 18, diagonal 2 was 24.
Mhm.
And I think you said it was 1/2, 18, and 24.
Mhm.
But then if only one of them changes, that's 12, and that's still 24. What is 1/2 of 24 times 12? Well, that's 144. What was this one? 18 times 24, 1/2? Let me go back up and
That
look.
was 216.
216. Okay, so we need to do 144 over 216.
Oh,
Tell me
then
what you get for that.
I get 2/3.
Very good. So the way this works is that you have to multiply both of the dimensions by this 2/3 to get the 4/9. If you only multiply one, it's just one dimension.
Yeah.
Okay. So our goal is to get through 2 lessons, and the next one is, it says kind of the same. It's like part 2. So we'll see what that's all about here. And great. All right, so you ready to get started on some new questions here?
Yep.
Okay, a circle has a radius of 5 centimeters. So they're telling you the radius is 5,
Mm-hmm.
and the area, what is the area? It's pi r squared, right? So that's pi times 5 squared, or 25 pi.
Yeah.
You see that?
Yes.
Now it says that the area is tripled. So which number are we tripling?
We're tripling 25 pi
So that's 75 pi. Okay. And now we want circumference. What's the formula for circumference?
is 2 pi r.
So we need the radius. The area is pi r squared.
Mm-hmm.
So see how the pi's cancel and r squared equals 75?
Mm-hmm.
What is the square root of 75? So can you reduce that for me?
Mm-hmm. Okay, I get 5 times the square root of 3.
Perfect. Perfect. Okay. So that's our new radius. So our circumference is 2 pi 5 squared 3.
Mm.
So it becomes 10 pi squared 3. Do you agree with that?
Yes.
Now, our original problem, the circumference is 2 pi r. What was our original radius?
5.
So 2 pi times 5,
That's
10
10
pi.
pi.
So how does 10 pi compare to the 10 pi squared 3? What's different about them?
It doesn't have the square root of 3.
Perfect. So you can see how that's the
Oh.
right answer there. Good. You worked through that perfectly. So notice that we can't really make any judgments, although we might say that it's the square root of 3. It's whatever k is,
Mm-hmm.
you take a square root of that. So remember how I showed you that thing when you were going backwards or when you're going forwards, like if you have a length,
Yeah, yeah. Area,
k,
volume.
area is k squared. Well, if you're going backwards, it's the square root, it's the square root of k, it's the square root of k squared, and so on. And we're gonna maybe see that in the next few questions here.
I see.
Okay. So kind of just an extension of that last problem that we did. Again, let's just go back and look at it real quick. The area was tripled. So the circumference was multiplied by the root of 3, the root of k.
Mm-hmm.
Here the area is multiplied by 6. Okay, so what
Right.
happens to, now they're asking about the radius, but it's essentially the circumference, because notice, we'll go back to this problem. I know I'm moving around a lot. The radius was 5, and then the new radius was 5 square root of 3. So that was multiplied by the square root of 3,
Yeah.
or the square root of k.
Mm-hmm.
So here, this is your k. So the radius is multiplied by,
Square root of 6.
yeah. Okay. Let's see here. All right, so let's do another one here. I'm gonna stop snipping in the answers. I think they're a little bit distracting here for us. The square has a side length of 9 inches. Okay, so let's draw a square.
Okay.
Okay, 9 and 9. Okay, now what is the area of this?
The area is 81.
81, and now it's doubled. So the new area is, what's the new area?
That would be 18, 18.
No. This is
Oh,
doubled, not the
oh,
side.
that's doubled.
It didn't say the side lengths were doubled.
Oh, that's 162.
Okay, so here's the side, here's the side. So side squared equals 162. And you take the square root of that. Can you take the square root of that number on your paper by hand, please?
Sure. So I get not 6, the square root of 2. Oh, I did I went down like I went to
81 is 3 and 27,
Mhm.
3 and 9, and then 3 and 3, right?
Yeah,
So
that's
there's pairs and pairs. Oops.
okay.
So for
I
each pair you bring one out.
Yeah, I forgot if you had to multiply or add them.
Oh, I see. Yeah, yeah. So it's multiplication.
Okay, yeah,
So
then
let's go back to original problem here. The new side length is 9 square root of 2. The new side length is 9 square root of 2.
mhm,
How do these compare? What happened?
they were multiplied by the square root of 2.
And k was, or k squared in this case was 2.
Yes.
Okay, so out of all, here's what we've done so far. Here are the 5 problems. In the first problem, k squared was 5. So
Yes.
k was the square root of 5. In the second
Yes.
problem, k squared was, let me scroll up and look, 3. So it was
Square root of 3.
the square root of 3. And in this problem, k squared was 2.
Yeah, square root
Square
of
root
2.
of 2. Okay, so in this problem, this next problem we're doing,
Mhm.
and get to it. Okay, a square has a side length of 7.3. Great. If the area is multiplied by 1/9, okay, so your k squared is 1/9.
Mhm.
What is the value of k? It's the square root of,
1/9.
and that's the square root of 1 over the square root of 9.
Yes.
What's the square root of 1?
Just 1.
Square root of 9?
It's 3.
Very good. So like these problems apply not necessarily to like anything that we're familiar with, but it's kind of like farming. It's like, okay, I can do it if a farm plot of land is this big, and then my 3 neighbors are going to join in. You can get some, you can maybe extend like some problems like this.
Yeah.
Okay, but we don't have a lot of we're not really thinking about that much
Mhm.
this much today. So
All right.
all right. Okay, so let's look at this problem here. And I think we got 2 more here. So this and 1 more. So I think we're gonna do great as far as getting through everything we wanted to today. All right, so it says an advertiser rents a rectangular billboard that is 44 feet wide and 20 feet tall.
Mhm.
Could you calculate the area of that for me, please?
Sure. $880.
880 feet squared, right?
Mhm.
And you're paying $15 per foot squared. So see how the feet squared cancel?
Yeah.
Could you multiply that number by 15 and give me your total?
13,200.
Okay, now so it says for billboard tight twice as tall. So which number changes?
It would be the 20.
So that's 40 and 44 now. Why don't you do the same thing? I want you to calculate the area and then multiply by 15.
I get 26,400 as my final answer.
So is that consistent with what it says there?
Yes.
Yep. Okay, so a similar problem here. Okay, so what was our K in this problem? Our K is that we were doubling.
Mhm.
Okay, but we're only doubling one dimension. So that's why that's why the 13,200 only went up by 2. If we double both dimensions, it would have to go up by 4.
Yeah.
Okay, so we're going to look at another example here. These are actually quite useful questions, I think, like, because a lot of the times the perception is, oh, if it doubles, then it must double, but it's not always true. Sometimes it's the square root of that number. Okay, Janet decides to sow grass in a rectangular plot that's 30, 30, and 25. Okay, so let's find the area of this, please.
Yep. And then I'm going to multiply that by 950.
Because each foot squared is $9.50. You've been looking at stuff online for things. Sometimes they're priced by the foot squared.
I get 7,125.
Okay. Now, if it's half the base and half the height. Okay. So see how both of these numbers are going down by half?
Yeah,
So this number has to go down not by half, but by
by
a
1/4.
fourth. A fourth. So what is 1/4 of that number?
1,781.25.
So she's paying too much if she
Yeah.
actually pays that. All right. Let's see how this went. All right. So we'll pick up tomorrow with some geometric probability stuff. We're really getting close to getting back on track. Thanks so much for scheduling, Christopher. Hope you have a great day, and I'll see you next time.
All right. Thank you.
You're welcome. Bye now.
Bye.